Okay, so here's what Brock told us. We're using this formula.
Oh, yeah.
Okay, that's the compound interest formula. Okay, so what's the P for this problem? 3,500, yes. What's the R? 0.0335. It says compounded weekly. How many weeks in a year? 52. And then what's my exponent? What's N? 52. And how many years? 6 years. So I kind of didn't give myself a lot of room there. But that exponent is 52 times 6. Okay? So we just put that in our calculator then. Now, for my calculator, when I put a fraction in, I need to put it in parentheses. Some of you guys don't have to do that with a little bit newer one. So it's 0.0335, oops, divided by 52. I just closed up for the fraction, and now I'm closing up for the 1 plus part. Okay? Now, how do I raise it to the 52 times 6 power? Caret, yeah, don't forget the caret. All right? And then I have to put it in parentheses. Some of you, again, when you hit the caret, not 0.6, sorry, times 6. All right? Some of you, it goes up in that spot for you, for your newer calculators. All right? And we hit that. So after the 6 years, compounded weekly, $3,500 is $4,278.91. Okay? So that's how we would do 40 through 42. We would use that formula. When it's compounded monthly, what's N? 12. Okay? When it's compounded daily, what's N? 365. Okay? So, does that help on those type of problems? All right, looking at the worksheet. Number 1 was decay because the base was less than 1, right? And if you do a quick sketch of these, this was pretty steep. I put it in my calculator, but it was pretty steep. Like that. All right, number 2 was what? Decay or growth? Growth, because 7 halves is 3.5, right? That's bigger than 1. Okay? And when we did our graph, it was pretty steep also. Not quite as steep as the first one. But growth, remember, goes that way. It starts out kind of flat and goes up. Decay comes down quick and then flattens out. Number 3, growth or decay? Growth. Okay, this one started out kind of flat and then gradually, excuse me. Thanks. Looks a little flatter, but again, it goes up eventually because it's growth left to right. Again, I'm not going to worry too much about end behavior stuff. We can look at the graphs to know what's going on at each end. Is this growth or decay? Decay. Because 0.8 is between 0 and 1, right? And this one was kind of flat too. It kind of looked like that. Okay? So again, I just got that from putting it in my calculator. Just remember to hit your caret button when you do that. All right. So number 5. Is that a growth or decay problem? Growth, because our base, 1.99, is bigger than 1, right? So, now, it was an increase because it's growth. What's the increase? What percent? How much more than 9, or more than 1 is it? 0.99, which is what percent? That's 99%, right? You move that decimal point 2 to the right, okay? And then estimate when the number of bacteria will be 1,000,000, okay? So I did it on the calculator, okay? And again, this is in thousands. You see that? So 1,000,000 is how many thousands?
1,000.
Yes, 1,000 thousand. So I'm looking in my table for 1,000 if you do the table way, or if you want to do the intersect way, you can do the intersect way. I'll show you the intersect way again. So I have to put 2 equations in. What's my equation? 100, and then it's 1.99 to the x, and then I want to make this 1,000. Okay, now for my window, let's think about this. All right, I want my y to be over 1,000 in my window, so I can see that y equals 1,000 line, right? And I'm looking at, this is hours, okay? So let's go up to 24 hours. Let's just do a day, okay? So to go, hit enter here, and then go to your window to see what we got. All right, so my X-Men, I'm just going to go from 0 hours to 24 hours. I'll go by ones. My Y-Man from 0. We'll go from 100 since that's what we started with, right? The 100 tells us what we start with, right? And let's go, we need to get to 1,000, so let's just go to 1,500. And what do you want to go by?
15.
Well, if we started out with 100, why don't we just go by 100?
Okay, yeah.
That makes sense? But you can go by 10s, okay, 20s. I'm just going to go by hundreds, and then hit the graph. There's my 1,000 line, okay? All right. So I hit window to get, from 0 hours to 24. I'm just thinking of a day. All right. 1 by 1, so my hours. And then I started at 100 because that's how many bacteria we started with. And then I just went by hundreds. And I wanted to make sure I was over 1,000. So I went to 1,500. Okay, so I just had to think through that a little bit. All right, so to find this intersection, you hit second trace, the button next to graph, and number 5. And then you just hit enter 3 times. First curve, second curve, guess. So how many hours? 3.346 or 3.5?
Oh, God.
Okay, 3.5 hours will get it to 1,000. Okay? Questions? So calculator, your graphing calculator will help you do that type of problem. So you'll need your graphing calculator for the quiz Friday. Yeah. All right. So 6 and 7, it says rewrite it in A1 plus R or A1 minus R to the T power. State the growth or decay rate and describe the end behavior of the function. Okay? So when you have this t over 7 or 4t, all right, we're going to break those up. Okay? So I'm going to rewrite this, first of all, as 3/2 to the 1/7 power, and then raised to the t. So I'm going to put that in my calculator. For this one, I'm going to go 0.9 to the 4th power, and then the t. So the reason I'm doing that, so I can see if that's going to be growth or decay, just one number in there. All right, so 3/2 to the 1/7, you just put in your calculator. 3/2 is 3 divided by 2, caret, and again, I have to put fractions in parentheses. So that's 1.06, we'll just make it.
Holy moly,
So is that growth or decay? That's growth, right? And we figured it would be because 3/2 is bigger than 1, right? What's the growth rate? 0.06, so that's 6%, right? We good on that? All right, the other one, we go 0.9 to the 4th. That's 0.656 or let's just do 0.66. Okay. Oh, we were supposed to write this like with 1 plus r, right? So we were supposed to do 1 plus 0.06. Now, how do I write this as 1 minus? Do I put 0.66? No, you do 1 minus 0.66, which is what?
Yep.
0.34, right? Okay, the 0.66 is 1 minus 0.34, right? So what's the percent decrease, decay? 34%. So that one's got like an extra step here. When it's more than 1, it's just 1 plus whatever that was after the decimal point. Here you're going to have to subtract 0.66 from 1 to get that 0.34. So you can write 1 minus 0.34 in that type of problem. Because it asked us to write it as 1 plus or minus r to the t power. Okay? Does it make sense? Okay. So the decay ones, you got to think a little bit more to it. All right, here's another, like the warm-up. All right? So the total amount is the principal, which is what we started with, 1 plus the percent, which is 0.0125, compounded daily, so n is 365 for 5 years. So my exponent is 365 times 5. Okay? So when you do that, you get, what do I get? $1,330.62. Okay? Questions? You didn't have to do 9, but we'll just go over it. Oh, it's not on there, so never mind. All right, so what is your homework today? Yeah, practice quiz. Okay? So, any questions? Is this starting to sink in a little bit? Not too bad, is it? All right, we just have some formulas we got to work with, right? All right? Okay. Good job.
Yeah, that would be